circles. All you really need to know is this identity, which you should already have notes written down from 5C, but write it down again because this is the significant one we are working with for 5D. So if I know either cos or sine theta, I should obviously be able to put the unknown in, put the known in the equation and then rearrange it to find the pair for that specific coordinate, whatever that could be. Okay, so what we're going to do is find possible exact values, so not decimal, exact values for cos theta if sine theta is 2/3. So that's a fact that we know. So possible exact values, probably there's going to be more than one answer. So let's have a look at illustrating that answer once we figure it out. So starting point is for you to use the identity. Now again, as I said, those little squared means that whole thing is squared. So when I substitute in this value, sine theta equals 2/3, I can just write it, instead of writing sine 2 theta, we read it as sine 2 theta, I'm going to put in the 2/3 and then square it. So if I square that, all I get is 4/9. So this is kind of the maths we have. All I need to do is have cos theta by itself. So I'm just going to take 4/9 from both sides. If I do that underneath a little bit, take 4/9. So if I use the calculator, 1 take 4/9, that's going to be 5/9. Now, I just have to square root both sides because I just got to get rid of the squared part. So I just need to go square root. And do remember that whenever we square root, what we get left over is a plus or minus answer option. So we actually have two answers. Now, this can actually be further simplified down to plus or minus square root 5/3 because square root 9 can come out of the square root. So this is my answer for cos theta. Sorry, I wrote that wrong. I should have cos theta, and that's what we wanted to find. So we found that answer. It can be plus square root 5/3 or minus square root 5/3. All I need to do is illustrate that answer. What does it actually mean? Well, in a unit circle, wherever that cos theta, sine theta is 2/3. So now, if I write the South Australian Tennis Club, I should be able to figure out whereabouts that sine theta equals 2/3 is. Sine is going to be a positive answer. As you can see, it's a positive 2/3. So what I can have my answer is, look at the SATC. These two are the only quadrants that I can have a positive sign answer. These quadrants, I can't have an answer that is a positive sign answer. These are not going to be the options. So I don't exactly care if I draw it like this or if I draw it like this. I don't exactly know what that theta is. However, if I just draw and illustrate some sort of angle and then draw another one, we try to draw it so it's symmetric. So that angle, whatever that angle ends up being, we'll try to rewrite that as that angle. Oh no, my unit circle's gone. So whatever that looks like, we're going to get two answers, coordinates, that have a sine theta of 2,3. So I already know the 2,3, which is the y coordinates. Now, we just found the x coordinates of it, the cos theta part of it, because it's going to be a positive square root 5/3 and then a negative square root 5/3. So obviously, the positive option is going to go on the positive side of x, and the negative x is going to be on the negative side. So that is how you illustrate your answer. You kind of see that they have the same y coordinate, which is how we got the same y coordinate, same height, and the x coordinate's a little bit different because they are on the other side of the origin. That's basically it. Okay, so now we get a little bit more constraint. We know sine theta. This time it's a negative, so we'll have a look at the other options. But we also get given this. Basically, they give us the domain they want us to look at. So I'm going to draw the unit circle again. I always like to start with drawing a little bit of a diagram just to kind of help with my understanding whereabouts it is on the unit circle. So I'm going to start with, I guess we'll start with this fact. Sine theta is a negative value. So if I write the SATC again, I should be able to estimate whereabouts, narrow it down basically. So sine theta is a negative value this time, so it's going to be these two quadrants I'm working with. These two are going to have positive signs, so I can't possibly have this answer to be satisfied. So I'm going to be working with these two. But what this this kind of fact gives us is it actually narrows it down further. So apparently my angle is going to be between pi and 3 pi over 2. If we go ahead and label all of the radians, so this is 0, remember that this is pi because it's 180 degrees. If I go another whole of 360 degrees, it ends up at 2 pi, so this can be written as 0 or 2 pi. This is half of the pi, so it's pi over 2. This is in between pi and 2 pi, so it's 3 pi over 2. So you can see that those are the 90 degrees, 180, 20, 70 degrees, and 360 degrees, but in radians. So what this is telling me is it's the same thing as trying to tell you that it's in between these two values. So it's telling us that it's actually restricting the answer to be in the third quadrant. So it's saying only look at that quadrant, please. So I'm not even looking at this quadrant anymore, even though that sine theta can be a negative 3 over 4. Because of this restriction, we're only looking at the third quadrant. Okay, so if I have a look, so let's just draw my kind of answer. I'm just going to draw a little answer. That coordinate is going to have a sine coordinate, which is the y coordinate of minus 3 over 4. All I need to do is find the cos theta, which is the x coordinate, and then the gradient of that line, which is tan theta. Easiest one obviously is going for you to find cos theta first, and then you will be able to easily find tan theta by finding the ratio. So what you need to do is substitute the value that you know. So minus 3 over 4 is a sine. So I'm going to write cos 2 theta plus minus 3 over 4. Make sure you're having a bracket. So just figuring the algebra. So 9 over 16. So if I take away 9, 16 from both sides. So make sure cos 2 theta is by itself. Just borrow the calculator. That is 7 over 16. So again, I need to square root both sides. And remember that when I square root both sides, I have two answers, plus and minus. And notice that 16 is a perfect square number, so it can come out of the square root like so. So cos theta can be plus or minus square root theta. But hold on, we are only looking at one solution. We're looking at the third quadrant solution. So looking at it, I can kind of see that we're looking at the third quadrant, so this value should be negative as well, because having a look, it's on the left-hand side of the origin. But also, looking at the t tells me tan can only be a positive value. So we're looking at, therefore, cos is going to be the negative option of those two answers, because the positive answer will be over here, but we're not looking at that section. So we know cos now, and what we're going to do is now find the tan, and in order to find tan, you just have to write the formula, which is sine theta over cos theta. So all you need to do is substitute in the value for sine theta, which is minus 3 over 4. We've got given it from the question over here, and then we need to substitute in the value for cos theta, which is minus square root 7 over 4. So if I do that maths, obviously you can use your calculator, but I'm going to try to show you how to use algebra. So that fraction, big fraction line turns into a divide sign, and then we can't figure out division of fractions, so we're going to change into a times, and then you just inverse it, so flip the fraction over, and then see if there's any kind of algebra you can do. I cancelled out the 4, so I get minus 3 over minus square root 7. Obviously the minuses cancel out, so I get 3 square root 7 as my answer. Okay, I'm just going to finalize my answer, just so it's a bit neat. So cos theta we found as this, and then tan theta we found as 3 over square root 7. So there you go, there's your answers. Give those 5D.1 a go, and then I'll do the next example in the next video.